Screen is visible, right, student? My screen is visible.
Yes, ma'am.
Students, today we want to focus on the new chapter, and that is your chapter 6 from this book, Ramesh Kankar, Microprocessor Architecture by Ramesh Kankar book. This is your module number 4. It will go with the syllabus. So make sure यहाँ पे जो लिखा है that is a chapter from the book. So easily you can map your content with your reference book. That's why I'm writing here chapter number. Previously, student, whatever we had discussed it in two parts. One is hardware section, where you will find your architecture, your pin diagram, and everything. Second, we discuss about programming, where we discuss about instructions related to different group, like data transfer, logical, machine control, and every group almost we have discussed. Only one group is remaining. Otherwise, all four we have discussed. If we go further, we discuss, suppose if we are writing any instruction, the important point that we want to make here that your processor is executing your instruction within how much time. The timing requirement for your processor information. So for that we had discussed a separate chapter of timing diagram where for each and every instruction we discuss how much time, how many machine cycle it will take from that machine cycle and T states requirement. You are able to comment on the timing related information for any instruction. Right. Now, student, we want to go further with the spec subroutine, with the timer and counter, with the code conversion, and finally, a very important part is interfacing. So that will be our remaining module. And now onwards, we will discuss on that. Make sure, student, if you don't know what is the timing requirement for individual instruction, you are not able to find the delay, right? So अगर आपको टाइमिंग रिलेटेड इंफॉर्मेशन कोई भी इंस्ट्रक्शन का नहीं पता है, हाउ मेनी मशीन साइकिल इट विल टेक, हाउ मेनी टी स्टेट इट विल टेक, so you are not able to find the delay, right? So make sure you will complete, you will make it very clear कि कैसे हम लोग मशीन साइकिल डिसाइड करते हैं एंड फ्रॉम दैट मशीन साइकिल हाउ वी विल फाइंड द टी स्टेट, राइट? हम लोग ने ऑलमोस्ट फॉर ईच एंड एवरी ग्रुप वी डिस्कस how many machine cycle, how many T state, and from that how can we find the equivalent timing related information. Right? So because that was microprocessors architecture, pin diagram, and in programming up to arithmetic logical group. That was a part of your mid semester syllabus. So I hope that part is almost clear to everyone. How was your exam, student? Exam कैसा, किसी को difficult लगा exam? Anyone find it difficult or it was good? Comment. It was good, Ritesh. Okay. किसी को difficult लगा exam? Anyone from you? They find it difficult? Okay. Good. Okay. So thing is कि almost 40% whatever we discuss up to today, that was your mid semester syllabus. हम लोग ने एक टाइमिंग डायग्राम नहीं रखा था, otherwise all things were covered. So I hope that part is clear. Now टाइमिंग डायग्राम का बेसिक पता है आपको, how many machine cycle you have, how many T state for each and every machine cycle. If it is clear to you, now things will be easy to identify for each and every instruction, right? That practice also we did in our class. So let me know in case of any problem, any doubt in that. Now today onwards we want to discuss, as I had mentioned, the new concepts which is related to stake subroutine, counter timer, and code conversion. And then finally we will go with the interfacing section. Right? In between, within one two lecture, one and two maximum two lecture, minimum one lecture, we will cover the interrupt part because basic is already known to us. So that is our planning for next 2 months, right? Now, to start with the stake and subroutine, definition of subroutine, or the understanding about stake and subroutine, few points that is in our mind, right? हम लोग को थोड़ा बहुत पता है what is stake, what is subroutine. Now, how to use this stake and subroutine into our processor, that we want to understand. Now, before actually go with that, can anyone tell me what is stake? What is stake? Yes. Almost 2-3 times we discussed in class. And as you are computer engineers, so that is known to you. Array of data. Okay, Manik. Array of data is stake. What do you think, student? What is stake? Chandy? Yes, the order will be first in, last out. First in, last out is not the order for the stake. Last in, first out. LIFO is the order, Chandy. Ritesh? Yes. So, LIFO data structure, that means how you are storing and how you are retrieving from the stake. That order will be always last in, first out. You all are correct with that. But my question is, what do you mean by stake? देखो स्टूडेंट, हम लोग लीफ ऑर्डर के बारे में बात करें, वी आर दैट इज नोन टू अस कि order to store and retrieve from the memory is last and first out. So what do you think, if you are storing and retrieving something from the memory, that means what you mean by stake? Stake क्या होगा? Just common sense. You are storing and you are retrieving the data from the stake and leaf order. So what do you think? What is your stake? Yes, correct. It is your memory. Now, Ritesh, we are having a memory like ROM, RAM, EEPROM. What do you think? Which type of memory? You can unmute and talk. There is no need to write. Ritesh? Memory is a
RAM.
yes, RAM. Very good. All right. So students, just make sure हम लोग जब भी whenever we are talking about state, we all are always giving answer LIFO. LIFO is to store and retrieve the data from the state. So last in, first out, we are storing, we are retrieving. So things should be clear. Stake is nothing but area into a memory. एरिया इनटू मेमोरी, राइट? अगर आपके पास रैम है, रैम, एनी एरिया ऑफ योर रैम यू कैन mention as a stake. You can consider as a stake. So what is stake? Stake is nothing but the area into a RAM. Now, as Ritesh mentioned, it is nothing but the memory. But for memory, we have four options. It may be RAM, ROM, EEPROM, ESQUARE which memory? So the RAM is a correct answer. It is a area into your RAM. Stake is what? Area into RAM. Now, suppose if I'll say I am having a RAM which is of 64 KB. मेरे पास RAM है 64 KB का, right? Now, out of this 64 KB, which area is mentioned? Which area can be considered as stake? What do you think? Out of this 64 KB, मैंने जो अपने प्रोसेसर से, we all know कि we are having a 16 address line, right? We are having a 16 address line. So this To this 16 address line, I can connect 2 raised to 16 different location. I can connect 64 KB RAM. Now, which area I can consider as a stake? Yes, what do you think? Which area out of the 64 KB, which area can be considered as RAM? Yes, students, are you getting my question? अपने अपने माइक्रो प्रोसेसर से 64 किलोबाइट मेमोरी इंटरफेस किया है, राइट? यू आर connecting 64 KB memory with your processor. So out of this 64 KB, which area can be considered as stack? Anjali, what do you think?
Ma'am, any?
N. So how you will identify through that N?
Ma'am, the stack pointer.
Very good, right? So that is the correct answer. Ki suppose if you say you are having a total memory available. Now out of this total memory, your stack you can define from any location to any location, right? The order will be your stack will grow up, right? आप जो भी स्टेक पॉइंटर में स्टोर करोगे वहां से आपका मेमोरी अप जाएगा. फॉर एग्जाम्पल इफ आई से माई yes. For example, if I'll say my stack pointer is loaded with the address C000, matlab C00 will be the last address of my stack. Right, whatever data I want to store onto the stack or I want to retrieve from the stack, that will be C0000 onwards, right? Downwards. Exact word is downward, right? So always top of the stack is defined inside this stack pointer. Am I communicating, student? आप जो भी स्टेक पॉइंटर में जो भी एड्रेस स्टोर करोगे, that will be the address from where your stack will start. But how stack will grow? From down to up, राइट? जनरली मेमोरी में स्टोरिंग और रिट्राइविंग कैसे होता है? मेमोरी में आप स्टोर करते हो, रैम में यू आर स्टोरिंग समथिंग, द मिनिमम एड्रेस इज 0000, मैक्सिमम एड्रेस इज FFFF, राइट? सो जो भी आपका प्रोग्राम काउंटर में स्टोर है या तो मेमोरी पॉइंटर में स्टोर है, सो दैट विल बी फ्रॉम अप टू डाउन, बट फॉर द स्टैक इट इज फ्रॉम डाउन टू अप. Am I communicating, student? Right? So if you say you are writing something onto the stack, just make sure आपने मेमोरी में जो स्टोर किया है, रैम में जो स्टोर किया है, that will from up to down, and whatever you are storing in onto your stack, that is from down to above. So make sure it will not overlap. Am I communicating, student? जस्ट जब भी आप स्टेक डिफाइन कर रहे हो, ओनली वन थिंग यू नीड टू टेक केयर इज अबाउट ओवरलैपिंग ऑफ डेटा. बिकॉज आप रैम में भी कुछ स्टोर कर रहे हो एंड यू आर स्टोरिंग समथिंग ऑन टू स्टेक एज वेल, but the direction of storing and retrieving of memory and stack is opposite, right? Top of the stack is stored into the stack pointer. From there, you can start to store, but you will go upward while storing. While in case of normal RAM, right, in case of memory, you are storing that is from minimum address to upward, right? So thing is, only one thing you need to make sure while initializing your stack is you need to take care of overlapping. That's it. Otherwise, any area of frame can be considered as stack. Am I communicating, student? Any doubt up to here? Anyone?
Ma'am, like when the stack is empty, then the stack pointer will point to FFF because
Yes,
it is from okay reverse.
yes,
Yes, yes.
yes. So whenever you will say that you are not storing anything onto the stack, you are mentioning, you can mention your stack pointer with FFF. So if you are pushing any data onto the stack, that will be from the last address, right? So there is no way to overlap. So always try to load your stack pointer with the maximum address that you have, right? So that will be a no chance, there will be no chance of overlapping. Correct, Ritesh. Okay? Okay, I hope this discussion is clear, student. Any doubt up to here? Now, as I had mentioned, any area into RAM can be considered, any area into RAM can be considered as a stake. So what you need to do is you need to load your you need to load your stake pointer. Now, how to load your stake pointer? So we know LXI is used to load 16-bit immediate data into the register pair. Right now, instead of register pair, here we are having a memory pointer which is pointing out to the top of the stack. So stack pointer, which is again 16-bit register. So whatever immediate data you are mentioning over here, that will be loaded into the stack pointer. Now your stack will start from this location. F. Am I communicating, student? तो जब भी आप स्टेक यूज कर रहे हो, whenever you are using your stake, the very first and basic requirement is you need to load your stake pointer. Are you getting me? How you will load your stake pointer? Obviously with LXI, right? LXI, why we cannot use MVI? Because MVI is used to load your 8-bit immediate data, but here our stake pointer is memory pointer, and that is a 16-bit register. So obviously we need to write a 16-bit immediate data here, and for that we are generally using LXI instruction, right? So whenever students make sure मैं repeat कर रही हूँ because there is an always observe, it is always observed कि आप स्टेक रिलेटेड सारे ऑपरेशन प्रॉपरली करते हो, बट इनिशियली यू फॉरगेट टू इनिशियलाइज योर स्टेक पॉइंटर. सो मेक श्योर स्टूडेंट, जब भी आप स्टेक यूज कर रहे हो, और वेरी फर्स्ट एंड बेसिक थिंग यू विल डू इज इनिशियलाइजेशन ऑफ स्टेक पॉइंटर. Any doubt, student, here up to this? In this two slide, in this discussion, any point that you want me to repeat? Anyone? Yes or no? Is it clear, everyone? Yes. Now, one, along with this, we had initialized our stake pointer with the maximum value. We are ready to use a stake. Which instruction can be used so that you can store the data onto the stake, or in case if the data is available onto the stake, you are able to retrieve it. Again, I am repeating, student, what is the use of stake? You temporarily, suppose you are writing any code and uh, you want to preserve your data, so that data you can push onto the stake, right? Suppose you are writing some code in between, you want some data to be preserved, and that you can preserve onto the stake. So that you are storing onto the stake. So how to store the data onto the stake, how to retrieve the data from the stake, for that you need some instruction, right? So push and pop. Push and pop, these two can be the instruction which will be the which can be used to write onto the stake, which can be used to write onto the stake and to retrieve the data from the stake. Am I communicating, student? जब भी आप डेटा को पुश डेटा को मेमोरी रैम पे स्टेक पे you are storing, so you are pushing your data onto the stake, you are sending your data onto the stake. So that can be possible through push instruction, push instruction. And whenever there is a requirement where you need your data which you temporarily stored onto your stack, you want to retrieve it, you can use pop instruction. So pushing and popping, that can be the two process through that you can use your stack, you can find, you can temporarily store your data, you can preserve it, right? You can retrieve it, and for that the instruction that can be used is push instruction and pop instruction. Now, how to use this instruction? We all know that the order that is followed by our stack is always leave for last in first out. Whatever data you are storing last, you are able to retrieve it first, right? मतलब जब push कर रहे हो data onto the stack, you need to take care. जब आप retrieve करोगे तो आपका जो last push होगा that will be first. Am I communicating, student? जो भी आपने लास्ट डेटा पुश किया है that you are able to access first. So that is the order that will be decided by the order of the stack. And here the order is followed by the processor is leave for last in first out. Now just try to understand push and pop instruction very neatly. You need to understand these two instruction, otherwise you will make a mistake, student. After push instruction, always register pair can be used. The syntax of or the format of the instruction is after push and pop, always register pair can be used. Right? As an operand, आप क्या use कर सकते हो? You can use register pair. So how many pair we are having? How many register pairs we are having?
Three.
3.
Three. B, C, D, E, H, L. Right? So out of these three, one more register pair we will discuss in our next few slides. But right now, so if I write push B, the content of register B and C can be pushed, can be stored onto the stack, right? Content of register B and C we have that will be stored onto the stack. Suppose we are writing push B am I audible now, students? Hello?
Yes,
Correct.
ma'am.
So what class we discuss? That you are writing push and then register pair. We can use any register. My voice is clear, student? Yes,
Yes, ma'am.
correct. So whether you are writing push B, push D, push H, any register pair out of these three you can use. What is the first requirement before writing any push or pop instruction? Before mentioning your stack, storing something onto the stack, what is the first requirement?
Load the stack pointer.
Very good. You need to initialize your stack pointer with the एड्रेस ऑफ स्टेक राइट आपको अपना स्टेक पॉइंटर में जहाँ से यू वांट टू स्टार्ट योर स्टेक दैट एड्रेस यू नीड टू स्पेसिफाई so student always keep in mind that whenever you are writing whenever you are using this push pop instruction your very first requirement is you will through LXI you will load your stack pointer with the memory address where you want to store your from where you want to start your stake, right? Now whatever the content of register B and C will be stored onto the stake. Whatever the content of register D and E you have that will be pushed onto the D. Now say same way with the pop instruction you can retrieve the content इन रजिस्टर पे रिट्राइव का मतलब आपका डेटा ऑलरेडी स्टेक पे अवेलेबल है डेट यू आर ट्रांसफर यहाँ पे रजिस्टर पेयर का डेटा यू आर पुशिंग ऑन टू द स्टेक मेमोरी पे स्टोर कर रहे हो रजिस्टर पेयर का डेटा यहाँ पे मेमोरी से रजिस्टर पेयर का डेटा मेमोरी से यू आर स्टोरिंग यू आर डेटा इनटू if you are writing it. Now, how storing and retrieving process can be using it very clearly. Suppose if I write, yes.
Ma'am, your screen is not visible.
Oh, sorry. Thank you, Anjali. Now it's visible. Anjali, it's visible now?
Yes, ma'am.
Correct, students. So what I discuss here, that whatever data we are storing and retrieving from the state and to this that can be through this, right? Now here, students try to very clear and backhand what is the process behind using push instruction and pop instruction. Now, student, as I had mentioned that whenever you are using push and pop instruction, the very first thing that you need to do is initialization of stake pointers. Suppose if I'm initializing my stake pointer with F, 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 F. Are you getting me, student? मैंने stake pointer initialize किया है. Let's say F, F, F. I'm will take place clearly. Content. We are decrement and then store. Again, I am repeating the process behind the push instruction is decrement and then store, decrement and then store, decrement and then store. But in case of pop, it will be retrieve and increment. Again, I'm repeating, student. While using push, it decrement and store. What is decrement? I'm talking about stack pointer. The address is first decrement by 1 and then it will store the data. While retrieving, while using pop instruction, it will first retrieve and then it will decrement. Please try to understand कि मैंने stack को initialize किया है f से, right? Maximum value of my memory that I'm loading for my stack. So this data, this 16-bit address is stored in stack pointer. Now if I write BC, if I write push B, whatever the content of BC pair, first my stack pointer will be decrement by 1. So decrement of SP. So f minus 1, that will become SP minus stack pointer minus 1. उस पे का data again SP minus 2, the content of C will be transferred over here. Get me, student? The storing will take place. And lastly, don't don't forget this part. And lastly, the state pointer will be modified as address. एक push instruction आप लिख रहे हो. Three processes are running in backhand. You are storing your register pairs content onto the stack and you are modifying your stack pointer as well. Right? Suppose initially my stack pointer is loaded with the maximum value. First it will decrement. My higher order registers value will be stored. Again it will be decrement. My lower order lower order registers data will be stored and stack will be modified next with the new address, and that is FFFD SP minus 2. Are you getting me, student? How this push instruction will work? Repeat any part, student? Is it clear? Again, I got disconnected or whatever.
Yes, ma'am, clear.
Yeah, it's clear. Okay, students, is it clear to everyone? Right? How push instruction will
Ma'am,
work? Yes, please. Yes.
ma'am, like we have to manually write DCR for decrement, or it will be
No,
happen
no,
automatically
no,
by
no.
push only.
Yes, it will be happen automatically, Ritesh. Right? If you are writing push, first it will decrement your stack pointer by 1, and then it will store your higher order register. Again, it will be decrement by 1. Your stack pointer will be decrement by 1. Your lower order register's content will be stored onto that location. Automatically, your stack pointer will be modified with the new address, which is SP minus 2. Are you getting me, Ritesh? Yes or no?
Yes, ma'am.
Correct. Anyone, any last point that you want to discuss? Is it clear, student? Let me know in case if you want me to repeat any part. It should be very clear, right? How to use push instruction. Is it clear to everyone? Yes or no?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
ultimately, yes, ultimately three processes can be considered while you are using push instruction: decrement of your memory pointer, loading of your register pair onto the memory, onto the stack, and updation of your stack pointer. These three processes will run in backhand if you are using your push instruction, right? So I hope this part is clear, right? So make sure student पहले higher order register का data store होगा and then there will be a loading of lower order register, right? So decrement store, again decrement and store, and it will be modified with the next address, with the address that your lower order registers content is stored. Student, make sure your push instruction is only 1 byte instruction. Whenever you will write push P, it will generate only one hex code and through that you are able to identify some data which is available into register pair has to be transferred onto the state, right? So I hope this discussion is clear. Now just try to understand POP instruction. So idea should be clear. Key push is used to store the register pair's content onto the stack. You are pushing the content of register pair onto the stack, while pop is used to, what is the use of pop? Pop is used to
To retrieve the data.
read the data or retrieve the data from stack to register, right? Now you are loading your register pair with the content of stack, right? Now as I had mentioned, whatever the content of stack pointer, that data available data that will be transferred into your load register. It will increment, first it will retrieve, then increment, 12 will be loaded into the register, higher order register. Again, it will increment and stack pointer will be modified with this address, right? So first you are retrieving, incrementing, retrieving and incrementing. So your stack pointer will be incremented, your modified with your final last address, which is F, 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 right? So if we are writing pop D, the content of the stack, which is mentioned by stack pointer, that will be transferred to lower order register. The next memory contain the address of the content of the next memory SP plus 1. That data will be stored into your higher order register. Again SP plus 2, your stack pointer will be modified with that particular address. So how to push the data onto the stack and how to retrieve the data from the stack. Is it clear to everyone? Anyone, any doubt? If you have, you can ask. Is it clear? Push and pop instruction? Yes or no? It's clear,
Yes.
students? Correct.
Yes, ma'am.
Now student, just make sure कि हमारे पास we have three register pair, which is BC pair, DE pair and HL pair, right? Now along with that, you can consider the pairing of accumulator with the flag register as well, right? Accumulator can be paired with flag register and combinedly it is known as PSW, program status word. Program status word is nothing but the pairing of accumulator and flag register. So accumulator we all know it is of 8-bit, flag register is also 8-bit. So combined it will make a 16-bit register pair, but that is known as a generally student जैसे BCD HL pair बोलते हैं ऐसे AF register pair बोलते हैं, right? It is not AF pair, but it is PSW, program status word, right? So the concept of program status word should be clear to everyone. That program status word is nothing but the accumulator and flag registers pair. स्टूडेंट अभी तक आपने जितने भी इंस्ट्रक्शन जितने भी प्रोग्राम इफ यू हैव ऑब्जर्व we don't have any provision to change the content of flag register. आप कोई भी रजिस्टर का कंटेंट चेंज कर सकते हो, कोई भी रजिस्टर में डेटा लोड कर सकते हो, कोई भी रजिस्टर से डेटा रिट्राइव कर सकते हो. यू कैन नॉट चेंज, प्रोग्रामर कैन नॉट चेंज फ्लैग रजिस्टर. दैट इज द रिफ्लेक्शन ऑफ योर रिजल्ट. आप अपना रिजल्ट चेंज करोगे तो ही आपका फ्लैग चेंज होगा. So earlier we don't have any provision to change a status of flag, right? We cannot change flag register, but now with the help of stack and push pop instruction, you can modify your flag as well, right? Now you have a provision to change the flag register as well, because you are considering the pairing of accumulator with flag register and combining, you can consider it as a PSW. किसी को आइडिया आ रहा है कि हाउ कैन वी मॉडिफाई द कंटेंट ऑफ फ्लैग रजिस्टर बाय यूजिंग दिस थ्री कॉन्सेप्ट? Yes. My question is, earlier we don't have any provision to change the flag register. Now accumulator can be paired with flag by using PSW. You can identify it. So is there any provision to change that content of flag? Yes. Students, what do you think? What is your view? No idea? Get an idea how to see? आप अपना PSW को push कर सकते हो, आप अपना PSW को pop कर सकते हो. तो see, just think of कि earlier why we cannot change flag, because आप flag को memory पे लेके जाओ ऐसा भी कोई provision नहीं था, आप flag को किसी और register में लेके जाओ ऐसा भी कोई provision नहीं था. Ritesh, are you getting my point? Why you are not able to change the flag content? आप क्यों modify नहीं कर पा रहे थे flag को? Because ultimately that will reflect your status. आपके पास ऐसा कोई भी instruction नहीं था कि जिससे you can transfer the content of flag onto the memory or onto the register. Ritesh, are you getting my point? Now you have that provision. So can you think of how can we do that? Rahul, what do you think? Vedant? Yes? Students, what do you think? Just any rough idea if you have. Just discuss. Anjali? Yes? Am I audible, student? Hello?
Like we can, if we can get using that stack push and pop, we can, if we can write in the flag memory, a flag register, then we can write any 8-bit data inside that, and like it will get modified.
Correct. Right, student, generally क्या होता है कि why we are not able to, as I discussed, why we are not able to, or we don't have any provision to change the flag, because we don't have any instruction through that we can transfer the content of flag onto the memory. But suppose, student, if we are writing push PSW, what it will do? If you are writing push PSW, what will happen? Your accumulators and flag registers data will be transferred onto the flag. Are you getting me, student? Suppose आपका accumulator का content 12 है और flag का content 80 है, मतलब आपके पास now you have provision to transfer the content of flag onto the memory. अगर मैं किसी और रजिस्टर में इसको पॉप कर लूँ रजिस्टर पेयर में, सपोज यहाँ पे मैंने accumulator और flag का content push कर दिया onto the stack, and if I'll pop it into B, that means whatever the register's content, register D's content, that is nothing but my flag register's content. Are you getting my point, student? Right? मैंने push PSW किया मतलब मेरा accumulator और flag का data memory पे चला गया. Now out of that, by using pop instruction, I can retrieve that data into any register pair, B, C, D, E, H, L. So now with this push PSW, I have a provision to take the data of flag onto the memory as well as register. So now अगर मुझे register D को modify करना है, then I may have so many options. If I want to retrieve, if I'm retrieving this into register E, for example, in any general purpose register, अगर आपने आपका flag का data वहाँ पे डाल दिया, Then you may have so many options to change it, to modify it. Are you getting my point, Ritesh? Yes, sir.
Yes, ma'am.
Students, Anjali, are you getting me? Ayush, Ankit, right? So अगर आप yes, Shreya, you want to say something?
No, ma'am.
Okay.
Yes, ma'am.
So okay. So suppose if you are writing push PSW, suppose you are writing push PSW, and after that you are taking the data, you are retrieving that data into any register pair. Now you have a provision. आपको अगर अपना रजिस्टर डी का डेटा मॉडिफाई करना है, ई का डेटा मॉडिफाई करना है, एल का डेटा मॉडिफाई करना, now your flag is onto the memory, onto the register, so you have a provision to modify it, right? So push PSW, very important to understand. काफ़ी बार इंस्ट्रक्शन को एक्सप्लेनेशन का जो क्वेश्चन पूछते हैं, हाउ टू एक्सप्लेन योर इंस्ट्रक्शन, उसमें काफ़ी बार दिस इंस्ट्रक्शन कैन बी आस्क push PSW, things should be clear. The process will remain as it is. Whatever the stack pointers contain, that will be decrement first. The higher order register, accumulator और flag में से higher order is accumulator and flag is lower order register. तो accumulator का data store हो गया. Again it will decrement SP-2 and the flag register's content will be stored onto the stack pointer -2, and use SP stack pointer will be modified with the top of the stack. Are you getting me, student? Right? Any doubt up to here, anyone?
Yes, ma'am.
So any doubt or it's clear?
Ma'am, one doubt.
Yes, Ritesh, please ask. No doubt, na? Okay.
Yes, ma'am. One doubt, ma'am. If
Yes.
suppose we are first we write the push PSW, and then uh, again we pop it into any register pair. So
Correct.
whatever changes we are making in those general purpose registers, that will be directly reflected in the flag register, or again we have to pop PSW, then it will be changed.
Yes, very good question, Ritesh. See, whenever you are pushing your data onto PSW, you are retrieving that data into any register pair. Matlab, now you are changing the content of your register pair, not flag, right? So if you want to reflect that change, again you need to push. Are you getting me, Ritesh? Right? And
Yes,
you
ma'am.
need to pop it into a PSW. Okay? You want to,
Yes.
if you want to make a reflection of that, that popping should be again in PSW, right? Then that change will be reflected. Very good question, right? अगर आप रजिस्टर पेयर में ट्रांसफर कर रहे हो and you are modifying the content of register pair, at that time it will directly not reflect into a flag register, but you need to pop it, right? Correct it? Correct, Ritesh?
Yes, ma'am. Yes.
Okay. Okay. Any doubt? Any last point you want to discuss here, students?
No, ma'am.
So, student, just make sure you will understand this stake related things, whatever we discuss in class for today. Make it very clear by today itself, and let me know in case of any doubt, right? Now, in next lecture, we'll focus somewhat on subroutine, right? So for that, to more instruction again we want to discuss. So that will be the content of our next lecture. Now we will focus on subroutine, right? Okay, just wait for 1 2 more minutes. I'm taking the attendance, and then you will do. Nancy, Rahil,
Yes, ma'am.
Palak,
Present, ma'am.
Pencil, Vishnu,
Present, ma'am.
Dev,
Present, ma'am.
Viraj, Priyansh,
Present, ma'am.
Priyansh,
Present, ma'am.
okay, Richa,
Yes, ma'am.
Anushri, Darshan,
Yes, ma'am.
Shivanand is present,
Present,
Bhavya,
ma'am.
yes, Bhavya, Raj,
Yes, ma'am.
Rahul,
Present, ma'am.
Kuldeep, Kuldeep, Kevin, Divyansh,
Present, ma'am.
Tarun, Yuvraj,
Yes, ma'am.
Yojit,
Yes, ma'am.
Kandar,
Present.
Chintan,
Yes, ma'am.
Prince, Bharat, Drashti,
Yes, ma'am.
Nilesh,
Yes, ma'am.
Hitansh, Aziz, Milan, Anjali is present,
Present.
Haresh, Henil, Smith, Tulsi,
Ma'am, 49.
Tulsi,
Yes, ma'am.
Smith, okay, Smith, Krishna,
Yes, ma'am.
Mani, Pooja,
Present, ma'am.
Janvi, Janvi, Ritesh is present, Madhavan, Parth,
Present, ma'am.
Shyam, Dev,
Present.
Isha,
Present, ma'am.
Siddharth, Pradeep, Yashvi,
Yes, ma'am.
Hinal,
Yes, ma'am.
Yash, Prachi,
Present, ma'am.
Shubh,
Yes, ma'am.
Chirag,
Present, ma'am.
Shivangi,
Present, ma'am.
Hardish, Shwati,
Present.
who is Hardish? Hardish, are you available? Shwati, Aditya, Ayush, Siraj, Sarju, Shyam, Vedant,
Vedant is present.
Vedant is present, right? Aman, Shubham, Ami,
Present, ma'am.
Kunj,
Yes, ma'am.
Kirtan,
Yes, ma'am.
Kushal,
Yes, ma'am.
Sachin, Neil,
Present, ma'am.
Trumil,
Present, ma'am.
Shreya,
Yes, ma'am, present.
Chirag, Pranav, Nandit,
Mahek, ma'am.
हाँ महक, Nandit, Ashish. Mahek is present, right?
Yes, ma'am. Present.